Hello everyone, I am Kushal. Today's subject is microcontroller. Let us discuss the DC motor and the controller. Then contents. Introduction to DC motor. DC motor principle. Motor torque and speed. Control DC motors. Control DC motor. Pulse width modulation. Hybrid motors and drives. Closed loop speed control. Feedback sensor. Safety and protection. Application and uses. Let us let us discuss the DC motor. Let us discuss the introduction to DC motors. DC motors are the fundamental electromechanical devices used in a various applications. They converted electrical energy into mechanical energy, countless everyday machines. Then discuss about the DC motor principle. Electromagnetism. A current carrying wire generates a magnetic field. Torque. The magnetic field interacts with a permanent magnet to create a torque. Rotation. The torque causes the armature to rotate. Communication. The device of a current is reversed to maintain a continuous rotation. DC motor utilize the principle of electromagnetism to convert electrical energy into mechanical energy. When current flows through a coil, a magnetism field is generated which interact with a permanent magnet. The interaction produces a torque. This causes armature, which is a rotating part of a motor, to turn to maintain a continuous rotation, a process called communication reverse. The direction of the current in the coil at appropriate times. Let us discuss the motor torque and the speed. Torque is a rotational force a motor produces measured in a network meters. It determines the motor ability to overcome loads. High torque means greater force. Speed measured in a revolutions per unit RPM indicates the rate of rotation. The relationship between torque and the speed is inversely proportional. A load increase the motor speed decrease and vice versa. This relationship is governed by the motor's characteristics and the load its driving motor selection involving balancing torque and the speed requirement for the intent applications. Let us move on to the next topic, controlling DC motor speed. Controlling the speed of DC motor is crucial for many applications. We can achieve these through adjusting the voltage applied to the motor. A higher voltage will lead to a faster motor rotation, while a low voltage will result in slower rotation. There are several methods for controlling the voltage to the motor, such as using a potentiometry, a volt regulator, or a pulse width modulation techniques. Let us discuss the detailed about pulse width modulation. Pulse width modulation, variable duty cycle. Pulse width modulation controls a motor speed by adjusting the proportion of a on time in a periodic signal known as duty cycle. Then speed control. A high duty cycle corresponds to a longer on time, resulting in a stronger motor current and a faster rotation. Digital implementation. Pulse width modulation is easily implemented using microcontrollers and their MOSFETs, allowing a precise control of a motor speed. Then let us move on to the H-bridge motor drivers. An H-bridge is a common circuit configuration used for controlling the DC motor direction and the speed. It's named for its resemble to the letter H. When diagrammatic, two sets of transition are arranged in a bridge-like structure, allowing current to flow in either direction across the motor. By switching these transition, uh, uh, the driver can apply positive or negative voltage across the motor receiving its direction. Pulse width modulation techniques are used to control the motor speed by varying the duty cycle to switch signals efficiently, adjusting the average voltage across the motors. We can see the circuit diagram of these motor drivers in this picture. Let us discuss the closed loop speed control. Closed loop control is essential for precious and reliable DC motor speed regulator. It involves monitoring the motor's actual speed and adjusting the control signal to maintain the desired speed. Speed measurement. Sensor like encoders to tachometers provide a feedback on the motor speed. Error calculation. The difference between the desired and the actual speed is calculated. Control algorithm. A control algorithm like a PID controller adjusts the motor voltage based on the error. Motor drivers. The motor drivers receive the adjustment voltage and the controllers the motor speed. This continuous feedback loop ensures that the motor speed remains stable and accurate even under varying loads or distribution. Feedback sensors. Potentiometry measure the shift rotation of a motor providing feedback on its position. Encoder generate the pulse that represent the motor rotational speed providing precious feedback for speed control. Technometer measure the motor speed directly providing a reliable signal for a speed monitoring and control. Hall effect sensor detect the magnetic field produced by a motor providing feedback to the position and speed control. Let us move on to the safety and protection. Overcurrent protection. DC motors can draw high current using fuse or a current breakers can protect the motoring and wiring for damage caused by overcurrents. Thermal protection. Motor can be overheated if they are overloaded or operated for extended periods. Thermal protection device can shut down the motors to prevent overheating and damages. Receiving polarity and protection. Connecting the motors to a power supply with reduced polarity can damage the motor receiver's polarity protection circuit can be prevented. This overload protection system detect when the motor is driving excess current. They can limit the current or shut down the motors to prevent damages. Let us move on to the application and uses of DC motors. Electric vehicles. DC motors are essential for powering electric vehicle. They provide the torque and speed control required for a smooth and efficient driving. Industrial automation. DC motors are used in a robotics arms, conveyor belts, and other industrial machinery to automate tasks and improve productivity. Unmanned aerial vehicles. DC motors are crucial for powering the propellers or drones, enable them to fly and perform various tasks like aerial photography and like drones, etc. They are used in that material. The DC motors are also used. Medical devices. DC motors are used in a pump for medical devices such as infuse pumps and ventilators to deliver precious and a controlled fluid or a gas flow. Thank you.